vectors show that angle PQR is right angled. So triangle PQR is right angled. A equals Q, where P is that, Q equals that, and R is that. So QP is P minus Q. QR is R minus Q. Remember, both going away from the angle. So what we get is we get -3, -5,5, -4,5,8, and we get 1, -10, -13, and on this side 7, 2, -1. When we pop this in the top, we get 7 minus 20 plus 13. You may have noticed I haven't bothered with the magnitudes, because what we get is we get 0 on the top. Because we get 0 on the top, it equals 0, which means inverse cos of 0 is 90 degrees, which means it is right angled at Q. All we need to prove when we're looking at proving right angled or perpendicular vectors is A dot B, i.e. the top line here, equals 0. So A dot B equals 0, which means cos theta is 0, which means theta is 90, so they're perpendicular. Right. So AB are perpendicular, find x. We've got a value missing, so we get two vectors here. So AB are perpendicular, then theta is 90, so cos theta equals 0. You kind of need to state that. Yeah, I've already said it twice now. Theta is 90, so cos theta, cos 90 is 0. So what we're looking for is we're looking for that top line to be 0. So we've got 2 times 2, -1 times x, and 2 times 0. So what we get is we get 2 minus x is 0, so x is 2 in that particular case. So vector A plus B minus k is perpendicular to these two vectors. So I'm going to walk you through this. So we've got position vector of the first one, of the second one, of the third one. I picked P, Q, and R. You could pick A, B, and C. It doesn't make any difference. So P is perpendicular to Q, and P is perpendicular to R. So again, theta is 90, so cos theta equals 0. So that top line's got to be 0. So when we bung it in, we get -2a plus 5b minus 4 is 0. And similarly on this side, hence I've written ETC, we get top line 5a minus 4b minus 7 equals 0. I'll look at simultaneous equations. Multiply top by 4, bottom by 5. We get 8a plus 20b equals 16 when we take that over. And 25a minus 20b equals 35 when we take that over. We can add the equations because there's a sign change. So 17a is 51, so a is 3. We substitute back in and we get b is 2. Now looking at the properties of scalar product, a dot a is the magnitude of a times the magnitude of b times cos of 0, which is just the magnitude squared. A dot b is the same as b dot a. When we're multiplying out, because it's like multiplying, a dot b plus c is a dot b plus a dot c. It's like a normal multiply out of bracket. Ka dot b is k times, because k is just a multiplier, it's k times a dot b. Or k dot a dot kb is k bracket a dot b, where k is an element of R.